So NVIDIA just dropped a new family of AI models called Nemotron H, and you're going to want to pay attention to this one. Why? Because they might have just cracked one of the biggest, most annoying paradoxes in all of AI.
And what's that paradox? Well, it's something we've all felt. You ask an AI a really tough question, you want it to think deep, and what happens? It gets so slow. It's been this fundamental trade-off, right? Smarter means slower. And that's been a huge roadblock for the entire industry. But why? Why does this even happen?
Okay, so it all boils down to this thing called the attention bottleneck. You know the basic architecture behind models like ChatGPT? It's called a transformer, and it's an absolute powerhouse, but it has this one giant flaw. For every single new word it comes up with, it has to go back and reread the entire conversation from the very beginning. Seriously, it's like having to reread a whole book from page 1 just to write the next sentence. And these models are doing that constantly.
So the bottom line is pretty simple. The more you ask the AI to think, the more tokens, pieces of information, it has to churn through again and again. It creates this massive computational wall. We've basically been hitting our heads against it, building these smarter and smarter AIs that are also getting slower and slower. And that's just not sustainable. It's a dead end.
So the big question is, how do you smash through that wall? Well, NVIDIA's answer isn't to just throw more power at it. No. They've gone and completely redesigned the core architecture. They're calling it a new hybrid engine, and it is built from the ground up for one thing and one thing only: pure speed. Okay, so what exactly makes this a hybrid? Well, instead of using all of those slow, traditional self-attention layers, they ripped most of them out. In their place, they've slotted in this new, super efficient alternative called Mamba 2. Think of Mamba 2 like a super smart summary of the conversation. It remembers the key points without needing to reread every single word. Now, they don't get rid of the old attention layers completely. They keep a few, only about 8% of the total, and they place them in really strategic spots where that deep, heavy-duty reasoning is an absolute must. So you get the best of both worlds, the lightning speed of Mamba 2 with the raw power of traditional attention right where you need it. But look, a clever design is just one piece of the puzzle. To really make this new engine an absolute monster, NVIDIA cooked up a pretty powerful secret sauce with the training process. And it really comes down to two key ingredients. First up is just sheer, mind-blowing scale. The biggest Nemotron H model was trained on 20 times trillion tokens of data. I mean, it's hard to even wrap your head around that number. It's like making an AI read basically the entire internet and then some. This colossal dataset is the foundation for everything it knows. But it's not just about how much data you throw at it. It's about the quality of that data. You've got to feed it a really balanced diet. So they gave it a massive serving of the web for general knowledge, a huge helping of code so it can understand logic and structure, and then a healthy portion of dense academic papers to teach it complex reasoning. This mix is what makes it so well-rounded and versatile. All right, the second secret ingredient is a really clever new training method called FP8 training. The easiest way to think about it is like this. Imagine you're doing math with super long, precise numbers like 3.14159. It's accurate, but it's slow. FP8 is like a really, really smart way of just using 3.1. It simplifies the numbers the AI has to work with, and that massively speeds up the entire training process. And get this, not only does it not lose accuracy, but sometimes this faster method actually produces better results. How cool is that? Okay, so we've got a brand new architecture and a smarter way to train it. That all sounds great on paper, but does it actually deliver? Let's throw Nemotron H into the ring against the current heavyweights and see how it really performs. So yeah, this is a head-to-head showdown. We've got Nemotron H on one side, and on the other, the top competition. We're talking Meta's Llama, Alibaba's Qwen, and we're looking at the only two things that really matter in this fight: accuracy versus speed. And boom, this chart right here basically says it all. So look, the higher up you go, the more accurate the model is. The further to the right you go, the faster it is. The place you want to be is that top right corner. Now, see where all the competitors are? Llama, Qwen, they're all clustered over on the left. They're pretty accurate, sure, but they're slow. And then, look way over there in the top right. That's Nemotron H all by itself. It's not a trade-off anymore. It's just plain winning on both fronts. So just how much faster are we talking? Well, when you give it those really long, complicated tasks, Nemotron H is up to 3 times faster than other models in its weight class.
That's not just a little bit better, that's a genuine game-changing leap forward. And the NVIDIA research paper itself is pretty blunt about it. They say, and I quote, Nemotron H 56B base outperforms Llama 3.1 70B on 16 out of 17 tasks that we evaluated. Now think about that. They put their model up against a bigger competitor, Llama's 70 billion parameter model, and it still came out on top in almost every single test. That is just pure dominance. Okay, so it's fast, it's powerful, we get it. But what's the use if you need a giant, expensive data center just to run it? Well, that's where NVIDIA pulls out one last trick. It's a really clever process called mini puzzle, and it's all about making this massive AI, well, mini. So mini puzzle works in 3 simple steps. First, the system automatically goes through the giant AI and figures out which parts are the absolute most important, the mission-critical neurons and layers. Then, it basically plays a game of Tetris, finding the best possible smaller design that can squeeze onto a specific piece of hardware, like a consumer graphics card. And finally, it uses all the knowledge from the big original model to quickly get the new smaller one up to speed, so it recovers almost all of its original smarts. And the result is pretty amazing. They took their 56 billion parameter model and squeezed it down into a much leaner 47 billion version. This little guy is another 20% faster, but here is the real killer feature. It's designed to run on a single consumer-grade GPU, the upcoming RTX 5090. I mean, this is huge. It yanks state-of-the-art AI out of the cloud and puts it right on the desktops of developers and researchers all over the world. So what's the big takeaway from all this? Well, remember that paradox we talked about at the very beginning, that you had to choose between an AI that was smart or an AI that was fast? What this new hybrid architecture proves is that, well, that was a false choice all along. We're stepping into a new era of AI where you really can have your cake and eat it too. You can have both. And that leaves us with one last really exciting question to think about. For years, the progress of AI has been chained to this fundamental speed limit. Now that that chain has been broken, what problems that we thought were impossible are suddenly on the table? What's this new generation of AI going to solve next? The possibilities are pretty incredible to think about. Thanks for watching.